Good evening, everyone. I hope you all doing well. As I informed, like today is the last day, so you have a test in the last 1 hour. Like till 8:10, Shashank sir will take a class. After 8:10, I'll be sharing the assessment link on the chat. So you have to take a assessment. Okay. So yeah, good evening, Shashank sir.
Good evening, ma'am. Fine. So good evening, one and all. Welcome to the last session, right? As ma'am just informed. Okay. Today let us discuss about a few things which I would feel a few of you might not know, right? Might not know, or a few of you might be aware also. Okay, so that is very important, and I felt that is one of the important things which needs to be covered as well. Okay, so let me first share the screen. Okay, so let us take it from there. So let me share the screen. Yeah. Okay. All right. All right. So before I wanted to yesterday itself actually I've given you a glimpse where I'll be talking about the role of Nvidia in generative AI, right? So what is Nvidia? What is the role? How these AI systems, what we are using, particularly companies like OpenAI, right? So how these people are actually using Nvidia powered GPUs, right? So let us try and understand the contributions of Nvidia also to the generative AI part. Now, before that, first I would like to talk about. We have discussed the practical aspects of GRU as well. Okay, and I just before just talking about transformers, because that is the current and latest technology which we are actually in the second generation of transformers. So we are in the second generation technology of transformers. So before talking about a transformer, I wanted to actually just talk about GRU as well, because few of you might remember GRU, because even in the practical part we have seen the GRU in action, gated recurrent unit, right? So all this started with the introduction, or all this started with the all this started with the foundation and development of the RNNs first. Okay, so CNN and RNN. So in deep learning, we had, I'm just giving you an overview or a glimpse, right? So the deep learning started with CNN and RNN, right? So CNN is convolutionary neural network, and RNN is recurrent neural network. So CNN basically deals with images, and RNN basically deals with text data. So as a part of RNN, right, there are different kinds of architectures which have actually come across. For example, like the LSTMs, right? From there, one step again, going into the, because technology, right? It keeps on upgrading, updating each and every day. So from there, RNNs, LSTMs came, right? So after that, the next level, it went into the GRU, right? So after GRU, the next level is the transformers. So now we are in the second generation of transformers. So this is the step-by-step path what has happened in the development of deep learning and AI, which is contributing directly to the field of generative AI. So basically, GRU, okay. So gated recurrent unit is basically an RNN architecture which is used for textual data. So this all things we have already kind of understood as well. Okay, so this is an alternative, or it is an upgrade. I would say not an alternative, more than alternative. It's an upgrade over the normal LSTMs. Okay, which had this problem of vanishing gradients. Now, this standard RNNs, why GRU was introduced, because of the long-term dependencies are required, and the problem of vanishing gradient has actually, has been faced by the regular RNNs and the LSTMs. Okay, so these GRUs helped basically to retain the memory. Okay, so how they actually contributed to retaining the memory is a very important concept is the very important concept is the gates. Okay, so I would say gates. A few of you might be knowing these gates, right? Forget gate, right? Update gate, reset gate. So those who have studied computer science might be knowing this. Okay, so you would have studied about the gates, right? AND gate, OR gate. In that we have different kinds of gates which are set up into GRU. So in a very simple language, okay. So because we have to make sure that even people from non-computer science background also has to understand. So in a very simple way to understand GRUs is basically these GRUs uses these gates. Okay, so these gates preserve memory. Okay, so what is required, what is not required. So based on the inputs, based upon the trainings, these gates will remember the data or remember the patterns, right, which is required for predicting the models. Okay, so that is what is basically the main intuition is about. So next, going into the advantages, it is a very simpler architecture as well compared to LSTMs, because LSTMs, the huge because I remember building many models in LSTMs before using GRUs. LSTMs are very tricky sometimes because gates are more. Okay, so that is the tough part when it comes to the LSTMs. So compared to these LSTMs, what these GRUs have actually done is they have actually helped better in training perspective as well, and it is also it has a simpler architecture. It is not that complex. Okay, so it is not that complex. Okay, but there are a few flaws in GRU as well. Okay, so in predicting the any sequential data, we have used the GRUs. Now our focus is just before telling the transformers, I wanted just to have a like a recap, right? So that is why I've taken the GRUs. Now after the real hero of Gen AI is the transformer. Okay, because he is the real hero of the Gen AI. After transformers have been introduced by Google, right, the entire Gen AI, what we are seeing now, has been developed. What you are seeing now and calling as Gen AI or generative AI is the foundation, or the entire thing is relying on the concepts of transformers. So many years, not many years, a few years they have built on first generation transformer, and now the biggest breakthrough in the 2025, actually this happened in somewhere around mid or later 2024, but in use with 100% research, the second generation transformers are introduced. So 2025 is a great year, particularly for Gen AI technology, because that is where the second generation transformers, and you will see a lot of leaps and bounds of AI and ML and deep learning technologies being implemented in each and every aspect of each domains, I would say. And to talk about transformers, the one word which comes to mind for me is the self-attention mechanism. So it knows what to give importance, what not to give importance, right? What is the context? What is how to deal with the context in the data, right? How to process fast, how to do the distributed computing, how to process the things faster, right, without losing its accuracy. It knows everything, right? So it knows everything, and that capability of a transformer is what makes the transformer technology very great, I would say, in the field of Gen AI. So the key components are basically, I told you, in simple language, if I have to say, the first one is it uses the word embeddings. So that is the reason I have covered all the aspects which, and I remember in one session telling that, right from the basic things of the technologies before the transformers, everything which is related to transformer also need to be learned, because word to vector model, word embeddings model, everything I've taught, right? Practical part also I've showed you. Why? Because this transformer is not something which came or it's not something came out of the box, right? It is not something like that. It is using all the previous technologies and correcting the problems, adding all the previous technologies, and then built as a new technology. So we can say it's a cumulative sum of all the technologies. So, when you want to understand the newer technology, what is relating to the newer one also, you should be able to figure it out, no? That how things are actually working out. So they have this input embedding, which is related to the word embeddings, right? And word to vector models, everything we have seen, okay, right? So all these things are actually related to that of a transformer. And the second point is the self-attention mechanism. So self-attention mechanism is calculates how much focus each word should give to every other word. That means they talk to each other inside. They have AI agents inside the transformer model. They talk to each other. They understand the scenario. They understand the context, what to give importance, what not to give importance, in which situation we have to give importance for what situation. So the entire the structure is built upon, or it is relying upon the self-attention mechanism. So the architecture, basically it has a encoder and a decoder architecture. Let us not go too deep, okay, because transformer architecture, entire transformers concept itself will take around some 5-6 hours to explain. So that's such a big architecture it is, okay. So if you are very interested, you can probably do your own bit of research in in understanding the or you can dig deep into the concept of transformer. So those who are very interested in generative AI will obviously start searching about or learn more about a transformer. In that process you will learn everything, don't worry. Because everything will come inside the transformer, so it will link to each and everything in the entire deep learning. It will, trust me. Okay, so you will end up learning deep learning at its peak. You will be very good at deep learning. You will start with transformer, you will end up with all the concepts of deep learning, and slowly you will be able to learn all the things as well. So that will happen eventually. So next thing is, let us see some of the real world applications. So I cannot say one, two, it is very difficult to give the real world applications. I should have removed this particular part also, because everywhere you're seeing generative AI, there is a transformer. That's it. I should have just put that line. So wherever you're seeing generative AI in action, there you will be, or there you are experiencing the power of transformer. Okay, so that is what the reality basically is about. So next is the architectures. Yeah. So architectures, again, I cannot tell, because there are lot of companies doing a lot of research. For example, like BERT. So BERT is one bidirectional encoder for bidirectional encoder, which is technology which is developed by Google, right? And then we have the GPT model, right? So GPT model we are using. Then we have the vision transformers. We have T5. We have many kind of transformer technology which is actually used. Now, let us go to the big part of today's session, which is the role of the company Nvidia in generative AI. Okay, so when we talk about generative AI, many people doesn't know that what powers generative AI is, Nvidia. Okay, there is also AMD, which also helps in the contribution of generative AI. But I just wanted to take Nvidia, because personally my favorite also, right? Because I've been following Nvidia for the past 20-25 years. Like 20 years, I would say. Okay, I'm not that old. So personally, around 20 years, I'm following Nvidia. So I know a lot about India. Personally, I really love the company Nvidia and what its contribution, and particularly in the last 10 years, right? So contribution towards the AI and generative AI has played more, more in the field what Nvidia is actually doing. So when we say Nvidia, right? So a lot of people only think Nvidia as a graphic card, right? So how many of you think that it's only a graphic card? It's not just about a graphic card. It is not just a hardware provider. Okay, it is a platform builder, it's an ecosystem enabler, and it is a research contributor. Okay, so to the field of generative AI, agentic AI, and AI agents. So probably you would have seen this person. He is the CEO, current CEO of Nvidia. Okay, so Jensen Huang. So basically, Nvidia is a US company. Okay, but all its, I personally, if you ask me, if you ask officially, it's US, but all the chips what Nvidia manufacture, everything gets manufactured in Taiwan. Okay, it's get manufactured in Taiwan. I think everybody knows Taiwan, right? So it is a different country from China. So many people think it's part of China, but not. Taiwan is a separate country. So Taiwan Semiconductor manufacturing company manufactures the chips of Nvidia. Okay, so what if I tell you the ChatGPT what you are using, right? So ChatGPT or the company OpenAI, right? They use Nvidia chips for powering their hardware. Okay, and I can give you hundreds of examples. The Microsoft Cloud, right? The hardware is provided by Nvidia, and what not. So like that, we can talk about many examples. Okay, so whatever chips are manufactured, Nvidia basically powering many of the generative AI things in the current day market. So next thing is, let us talk about bit technical also. A few people might feel bit difficult to understand if you are not aware entirely about the GPUs. Okay, so you can just concentrate, don't take it too hard on your head. Okay, so just try to relax and understand what exactly is these chips which powering the generative AI. So the first thing is hardware powerhouse. Okay, so there are a few chips like A100, H100, and now B100. These are basically the backbone of the large language models. So we have understood, no, the LLMs, right? So the LLM models like the GPTs, Llamas, Claudes, what you are using, all uses the GPUs which are based upon these three technologies: A100, H100, and B100. Now the training what your ChatGPT or the OpenAI basically use, it is powered by Nvidia GPUs. Okay, so the next important thing is, I told you also, I think in yesterday's session, I was telling you that tomorrow's session, I will tell you about what is a CUDA core or what is a tensor ray tracing, right? So CUDA, right? So CUDA is nothing but a core. Okay, so you can think of CUDA as a framework, right, which actually helps training, you can think of like generative AI. Okay, or if you know very well about TensorFlow, PyTorch. So all these frameworks are powered or helped by the GPU, which is the concept of GPU acceleration. So GPU acceleration, I will tell you in detail. That is one big concept as well. So I'll tell you that. So next thing is the ray tracing. So ray tracing is nothing but which helps things to be better in the real-time applications. For example, these are mostly used into the deployment. Okay, so those who game are very well aware. Okay, because your students, many of you might be gaming, you might be knowing well about ray tracing. I did not tell you. Okay, so coming, let us not talk about gaming part. Okay, here we are not talking about gaming part. We are here to know about the link of Nvidia with the generative AI. So this tensor ray tracing is basically helps in processing the real-time applications. So like that, you can remember. And the next thing is the Nemo and BioNemo. Okay, so this BioNemo and Nemo are basically generative models. Okay, or you can say it is a training and tested customized models. Okay, so like that, that much you can remember. That is more than enough. Next thing is the supercomputers. Okay, so the data centers, the data centers or the entire supercomputers foundation most of them are actually powered by Nvidia. For example, Nvidia is powered for generative AI for cloud-based infrastructure with companies like AWS, Azure, and GCP. Right. So these are the three big players. And for this infrastructure for cloud-based and generative AI, everything is provided by Nvidia. Okay, so AWS is Amazon Web Services, Azure is Microsoft Azure, GCP is Google Cloud Platform. These are the three cloud providers in the world. Okay, you have only three cloud providers in the world. Okay, that is AWS, Microsoft Azure, and GCP. So all these three use are, I checked twice to make sure. Okay, all these three companies are partnered with Nvidia for the infrastructure. Okay, so next thing is role of agentic AI and AI agents for in the field of how the company Nvidia is actually transforming or helping in the field of agentic AI and AI agents. Let us try to understand. So the first one is the multi-agent simulation. So we have talked about the simulation. Remember, so simulation is nothing but creating a real-time environment. Okay, so it is basically creating a real-time environment to you'll not be able to figure it out whether it is a simulation or a really real time. Okay, so that difference you'll not be able to identify. That is the for powering all these doing simulations and all these things, the infrastructure and the hardware which is provided by Nvidia. So the next thing is Isaac. So I think yesterday only we have spoken about this term Isaac, right? So Isaac and Jetson are two platforms. Even this Xavier also, Javier, actually it is Javier. So Isaac SDK and SIM so enables the development of autonomous robots and agents with visual and physical intelligence. So Jetson Nano and Javier are AI edge hardware running computer vision, sensor fusion, and decision making into the real world robots and drones. So about drones, I need not tell you, right? So even with the current different wars, you are able to see that people are fighting using the drones, right? So that much of even the drone technology is powered by Nvidia. Okay, yeah. So let us go to the next part, which is CUDA accelerated RL. So RL is nothing but the reinforcement learning. So for CUDA accelerated, we have CU, DNN, and CUDA BLAST. Okay, so these are the two reinforcement libraries which are used for this CUDA course. Okay, so next thing is NVIDIA ACE for digital humans. Okay, so probably you would have heard or not heard, there is something called as an avatar cloud engine. Okay, avatar means don't think it's a movie. Okay, they have named it as avatar because this avatar is the gaming, the customer service and education, everything, whatever the generative AI, whatever that is been the cloud services or access the infrastructure, everything is provided by the NVIDIA ACE. Okay, this ACE is nothing but the avatar cloud engine. So this basically uses the facial animation, the emoji detections, and everything for the games and all. Okay. So next, yes. So next, going into the research and ecosystem of NVIDIA. So going into the key research contributions, right? So again, we cannot we cannot put the contributions of NVIDIA onto a slide. Okay, we cannot limit that. That is immense. And so if you search articles on generative AI, which are actually created or which have been researched by NVIDIA and Google, you will get some thousands and thousands of articles. Right. So right from the diffusion models, reinforcement learning agents, multi-models, AI simulations. Right. So for everything, the research and the ecosystem team is contributing. So they have an open source tool which is called as a Megatron LM. Okay, so LM is nothing but a language model. Okay, so this is basically used for a transformer training. Okay, so Megatron and transformer. So people who would have watched this transformer movie might be thinking that these these words are somewhere connected to the movie. Yes, I don't know exactly the movie used these terms, or these terms are used by the movie. Vice versa, that I'm not sure actually. I've not checked that much, because what is the use of trying to find out that who used what? It doesn't matter, right? So so I have not checked. Probably you can you can try and have a go, in understanding that, because even the word transformer relates to the movie of Transformers. Okay, this Megatron, all these things are there. So when I look at this, I remember that as well, because even I watched those movies. So so this Megatron is basically a transformer technology which is basically powering these language models. Okay, so that is the tool which Nvidia actually uses. So next is the collaboration. So collaborations, again, we cannot justify the collaborations also, because each and every company, for example, even Google, right from Google, Microsoft, Apple, right? Apple has its own team, but they are actually now trying to collaborate with Nvidia as well, because they know the power of Nvidia. Okay, so Apple has its own ecosystem, but now it is entirely changing as well. So they're trying to collaborate as well. So all the big companies in the world actually have the collaboration. For example, best example for generative AI. Okay, let us not talk about the other collaborations. Let us not go that far. But talking about the generative AI part, one of the companies which comes to my mind is the OpenAI. So OpenAI, because ChatGPT is one tool which we use in our daily life, right? So that is a product of OpenAI, which is that company uses the hardware of Nvidia. So the Hugging Face, Stability AI, all these generative models are basically used. Now, let us see, let us try and understand one case study to understand how NVIDIA is actually, contributing to the field of OpenAI. Okay, so all the models, like, even the image generation tools you are using, right? So DALI, Codex, ChatGPT, all these are powered by NVIDIA's infrastructure and NVIDIA's hardware. So the background is, OpenAI develops foundation models that require massive computing power, high memory bandwidth, efficient parallelism and scaling, low latency inference. Okay, so for this they need a lot of parameters. So there is a one word which is called as transistors. Okay, probably you would have heard. Okay, so this requires thousands of years to train, but because of this, the billion parameters and transistors which have been developed by the Nvidia chips, it is very easy to train those data sets, but these cost so much cost to build them. So next is how Nvidia powers OpenAI. So we all know that OpenAI is one of the biggest companies which uses the infrastructure of Nvidia. So probably if you have not known before, at least now you would have known that the company OpenAI, the company OpenAI is being powered by Nvidia, right? So they basically use two chips. One is A100 and H100. Okay, so OpenAI uses Nvidia's A100 Tensor Core GPUs for both the training and inference. Okay, so latest, I would say, I would say that it went on to Hopper architecture. Now I'll talk about the current architecture also, because the current architecture of Nvidia, which is using the second generation transformers, is Blackwell technology. So Blackwell architecture also we will speak. There is a lot. It is so much in the development phase, and it is before that they had this Hopper architecture as well, which is still this Hopper architecture is being used by the OpenAI, because it will cost millions for the companies to change the architecture and buy the supercomputers. It's not just you go purchase one laptop with an Nvidia graphic card. No, it's not like that, right? So the graphic cards which we use are just for basic Gen AI tasks and basic things. But you think about a company, right, like OpenAI, right? It is powering the entire world. So across the world, ChatGPT, people use. So it should be stable, and whenever you search something, it is coming. No, it is not saying that please wait for 5 minutes, I will give the answer. No. So they need supercomputers to power this. All right. So that is why staying on one architecture, uh, you know, moving from one architecture to the other architecture for the company who is building it, it is fine. But the problem comes for the companies like OpenAI, right? It's not easy for them just to shift like that. So what are the key benefits is they have this mixed precision FP16 and BF16 for the faster computation. They have this higher bandwidth for handling these larger models. And there is NVLink and NV switch. Sorry, NVLink and NV switch for faster multi-GPU communication. Right? There is one line in the last which you need to read. Without NVIDIA's A100 GPUs, training a GPT model would take years, not weeks. Okay, so that is what Nvidia has done to the companies such as OpenAI. Okay, so yeah, if you have any doubt, you can ask me in the meanwhile. I just have my water. So you can just ping it in the chat if you have any questions. Okay, so if you have any, just ping it. Okay, I'll just move forward. Okay, let us not waste that much time because we have only till 8:10. Okay. So next is the next thing is I think question. No, I didn't get it. Okay. So next thing is the supercomputing. So if you have any question, you can just ping it in the chat. Few people are raising their hands. You can just put it in the chat. Okay, so that will help me to answer the question. So next thing is supercomputing, NVIDIA's DGX and Azure's supercluster. So many people would have not known about Azure. Okay, so Microsoft Azure is one of the cloud platforms which powers a lot of organizations around the world. Okay, so a lot of companies use Microsoft Azure as their cloud partner. Okay, and the biggest collaboration I would say is the OpenAI's collaboration, rather than I can say Microsoft's collaboration with OpenAI. It should be correct. I'll tell you why. Because Microsoft doesn't have this generative AI team. Do you know that? Yes, it's such a big company, but they don't have this generative AI team. This like how Google has Google's brain team, right? Which use or build these technologies. They don't have that Microsoft. Many people don't know this, right? So that is why to stay in the competition of generative AI and to power their particular cloud services as well, they have actually collaborated with OpenAI. So this has actually happened in the recent, because they feel that this in the race of generative AI they had to stay forward. So this Microsoft Azure's OpenAI cloud partner built an AI supercomputer using tens and thousands of NVIDIA's A100 GPUs in coordination with OpenAI and Nvidia. Because when you say OpenAI, the infrastructure which is provided, the hardware which is provided for OpenAI is Nvidia. So definitely Microsoft, you can say that they have you would say direct or indirect, what is there? They have collaboration with the Nvidia as well. So DGX A100 systems, they are basically the super node computers. Let us not go too much into technical. So this basically powers all the ChatGPTs, codecs, DALIs, everything you're using in real time. They are powered by NVIDIA. So next thing is the CUDA ecosystem. So in the CUDA ecosystem, you have two libraries. One is CUDA DNN, and we have seen, right? And you also have this powered by the language models, which are Megatron also. So inference acceleration, the NVIDIA's Tensor RT is nothing but ray tracing. Okay. So and Triton inference server helps OpenAI optimize real-time deployment of LLMs. Okay. So enables what this acceleration actually do is it enables the ChatGPT to deliver faster responses to millions of users. That is happening by this Triton inference server and the Tensor RT, which powers, which is, to happen. This the hardware is very important, right? So that hardware is provided by NVIDIA. So yeah, probably we can, results and impact. The training time is basically reduced, to months from months to weeks using the A100 GPUs. And model deployment, you know what ChatGPT is actually doing, right? I need not tell you, right? So it is very fast, it is very responsive. It is using the Triton plus Tensor ray tracing cores for achieving this real-time acceleration. So the cost efficiency is a mixed optimization. So obviously it will have a bit of high price as well. So the next thing is ecosystem development. So accelerated via this NeMo, CUDA-X, and Megatron is what the technology is actually happening. So these strategic collaborations, I told you already, OpenAI's collaboration with Microsoft Azure with built on NVIDIA's GPU backbone. So they three have formed a big trio. Okay, we should see what advanced things actually happen, because now Microsoft is completely collaborated with NVIDIA and OpenAI to power generative AI. So OpenAI and Nvidia, so contributions have already been happening from a lot of years, right? And the next key takeaways basically are massive generative models are only possible. This sentence I really love. They are only possible with Nvidia's compute infrastructure. Really trust me, guys. If there is no Nvidia, probably some other company would have come. But you cannot compare Nvidia with any other company. That is a problem, right? So usually, for something you have only one or two options, three options. For example, I'll tell you, for a few things there are only very limited options, right? If you want to buy GPUs, you should only buy a couple of companies. One is AMD and one is Nvidia, right? So any one you have to buy. And if you want to buy processors, it's only two companies, Intel and AMD, right? You don't have a third company. So probably if you don't like Intel and AMD processors, there is no other option. You cannot use a computer. Forget about using a computer. So you have to buy one. So like that, and GPU, you have to use Nvidia or AMD. There is no other third option. So cloud services, you have to use Microsoft Azure, or you have to use Amazon Web Services, or you have to use Google Cloud Platform. So only three players are there. So there is no fourth alternative. So like that, a few things are only limited. So you cannot go beyond that, and you cannot explore, because such companies doesn't exist. So next is OpenAI depends on NVIDIA, not just for hardware, but also for scalable training frameworks and deployment tools. So NVIDIA is the invisible force behind real-time AI tools millions interact with daily. Yeah, now now more than this, this line, now I'm liking this particular sentence. It is the invisible force, right? A lot of people. So that is why I just wanted to bring NVIDIA into the picture as well, because to understand the power of generative AI, which is currently happening, and who is the biggest infrastructure or hardware provider behind all these things, right? So next, let us go to the very important thing. And personally, I'm just very excited also to see what are the advancements which happen in the NVIDIA Blackwell architecture, because this Blackwell architecture is what with this the second generation transformers have actually been launched, right? So this has happened, this architecture has been launched last year, right? But the era of generative AI using this Blackwell architecture for the common people has been launched this year with the new GPUs, RTX 50 series GPUs, which are launched by Nvidia. But these are, these are actually being used 1 year before for the supercomputers, right? So already these are, using this for LLM models, right? Generative AI and for high performance computing. Okay, so they say that Blackwell introduces groundbreaking innovations across both data centers and consumer platforms. Because, see, as a normal consumer, apart from that, it is also very important which powers the data centers. So I think you know what is a data center, which stores all the data like a center repository, right? So for this, you need a hardware. So the key highlights for this Blackwell architecture basically are the billion transistors. Okay, so 208 billion transistors have been okay, so it's not 208 transistors, it is 208 billion transistors are achieved to put together in the production of making a GPU by Nvidia. 208 billion is unbelievable. So small transistors which help in faster processing and computational power, right? And as I told, this is basically the entire Nvidia chips are basically manufactured by TSMC. Okay, so I told that they, even though it's a US company, people remember Nvidia as always a Taiwan it feels like it's a Taiwan company because all the manufacturing, right, all the employees, all the big heads, everybody is from Taiwan. Even the CEO of is actually from Taiwan. Okay, so it's a US company. Actually, the CEO should be a US person, right? So, but no, it's not. Even the CEO is from actually Taiwan. So just for namesake, it's a US company. So manufacturing process is for NP is nothing but a nanometer process. Okay, so which is optimized for performance and efficiency. So die configuration features two reticle limited dies converted via 10 TB of chip-to-chip interconnection function as a unified GPU. So yes, and this is what I am also waiting for to show you. It's a second generation transformer engine. Okay, so this particular I would say the second this particular Blackwell architecture is basically the second generation transformer engine. So what Nvidia is claiming is it has more enhanced tensor cores, okay, and accelerated LLM. So we will talk about accelerated GPU in a bit. Okay, so this is basically designed to handle over some 10 trillion parameters. Okay, and it uses the technology of FP4. FP4. Okay. So yeah, let's skip this. Fine. Next is confidential computing. Okay. So the secure AI processing. So the first GPU to support TEE, which is trusted execution environments, ensuring data and model protection during the AI training and inferences. So the performance delivers near identical throughput in encrypted modes compared to unencrypted operations. So the advanced NVLink, so high-speed connectivity, 5th generation NVLink offers 50 GBs of per link with up to 18 links per GPU. So totaling, this is all about the technical aspects. Probably you can just check it later. So one more important thing is the DLSS4. Okay, so DLSS4 is what the technology, what Blackwell, which is introduced in the Blackwell architecture, which is powering the second generation transformers. DLSS is nothing but deep learning super sampling. Okay, so I was telling you about deep learning, right? So deep learning, so it uses deep learning because entire transformers is relying upon deep learning, right? So deep learning super sampling is what DLSS is basically about. So what this DLSS4 technology, so DLSS 1, 2, 3, 3.5 is also there. 4, all this technology is actually being found or researched, I would say, by Nvidia. Okay, so they are the patent and owners for this DLSS technology. So this DLSS4 introduces a multi-frame generation, boosting frames rates up to 2x over previous versions. So that is what they're claiming, that yet to be seen, and how that will impact in the generative AI part, that is what to be seen, because it's a new technology, DLSS4, right? And the second generation transformer is what something new which has been launched. So this is basically a transformer based model. So utilizes the transformer architecture for improved image quality and stability in DLSS super resolution. Okay. So SS is not super resolution, SS is super sampling. Okay. So DLSS means deep learning super sampling, super resolution, and ray reconstruction. Ray is nothing but putting the things into frames where it looks very real. Okay. So next is the power efficiency and the max-Q innovations. Okay. So advanced power gating. So many of these GPUs which are actually launched by this Blackwell architecture are using a lot of power. So that also they have put that max-Q technology in order to reduce the power consumption. Okay. And to process very faster using less power consumption, because there is something called as a latency. Okay, probably in TVs when you are buying, you would have seen this auto latency. Okay, so this latency also helps in the building of these GPUs as well. So this low latency sleep states particularly enables the GPU to enter deep sleep 10x faster, conserving power during idle periods. So something is not happening during the idle period, it is going to save the power. So this is what low latency actually brings to the table. So accelerated frequency switching allows clocks to adjust to dynamic workloads 1000x faster than the previous generations. That is what I told, that yet to be seen how the second generation transformers actually perform. Okay, so this consumer GPUs which you can see, that is the RTX 50 series graphic cards, which actually these are the graphic cards which as a normal consumer we actually use. Okay, so each graphic card, whether it is a low-end graphic card or a high-end graphic card, they have a few things called as CUDA cores, right? These CUDA cores are which powers or which performs or which is used to do the tasks. Okay. After that, they have these tensor cores. Okay. Currently we are in the 5th generation tensor cores. Okay. And the next thing is the RT cores. So RT cores are nothing but the ray tracing cores. Okay. So after that, how much amount of graphic card, and till this previous generations of graphic card, we have only till DDR6. Now we are having the DDR7 technology as well, and also they have this memory bandwidth, and then we have the peak performance, which is the T-flops, and then the total power consumption, which we call as a TGP. Okay, which is total graphics power. So this is the high-end one, 5090, RTX 5090. The second best is RTX 5080. Okay, so which has memory up to 16 GB. Okay, and the next one is the 5070 as well. We have, okay. So see the ray tracing course, 192 was the highest. Then it came down to 84. Then from there we have 48, and then even 5060 is also there. I'm not sure. I just kept only a couple of things. Okay, this is not that very important. Just you need to understand that what actually a graphic card actually contains for a normal user. That's it. Apart from that, not much of use for common people. So 24,000, 10,000, it came down to 6,000. Okay. So next is let us talk about the data center and AI applications. Okay, so 8. So any questions you have? If you don't have any, I'll just continue. So if you have any, just you can post it. Yeah, just before the exam, I think another 10 minutes I can take. So any questions if you have on the entire thing, you can just talk about, or sorry, you can just ask me any questions if you have any. Okay. So data center and the AI applications. I opened my chat also. If you have any questions, please you can ask me. Okay. Yeah. So the current Blackwell architecture, what Nvidia is basically uses this Grace Blackwell super chips. Okay. So these are combining the Blackwell GPUs and the Nvidia's ARM based or Grace CPUs for high performance computation. Okay. So there are actually two kinds of architectures, particularly what powers the CPUs. So one is the x86 architecture and the other is the ARM architecture. Okay, so not many might be knowing or few might have actually known. So it's ARM architecture and it is x86 architecture. Okay, so all the Intel CPUs and AMD CPUs use these x86 architecture. Okay, the ARM architecture is used by Apple. Okay, for the MacBooks. Before they used to use Intel and AMD processors. But now they're using the ARM architecture. Their M1, M2, M3, M4 chips are powered by ARM architecture. And apart from that, you know Qualcomm Snapdragon, right? So many of you use Qualcomm Snapdragon chips into your mobile phones. Okay. So many of you don't know that Qualcomm Snapdragon chips are also there. There are laptops which power this Qualcomm Snapdragon chips. Okay. So they also use this ARM architecture. So ARM architecture is supposed to become famous, but that has to be seen. So mostly it combines this ARM architecture and the Blackwell GPUs, what they have. Okay, these data centers do that. Okay, because they want the best. So whatever is the best, they are going to combine for these data centers. So I got a question. Performance with GPU. Performance with the GPU with AI. No, that is not a proper question. Is better or without AI is better? So you want, okay, I understood. So you want performance, yeah. Okay, so the performance of AI with the GPU and without GPU, correct, Parthiv? With the GPU and without GPU, that is actually I don't think so. That's a question because you know the answer for that. Just you are asking me. Obviously, AI or generative AI or AI agents or agentic AI, it is better with a dedicated GPU. Obviously, it is better with a dedicated GPU and particularly GPUs like Nvidia. But there is one thing. Intel is trying its best to stay with the GPU part to give a good competition without using the Nvidia GPUs. But that always remained a question mark because CPU wise, Intel is really good. Currently we are in the 14th generation processors, right? So processors wise, they are good, right? I will not deny it because I use both Intel and AMD chips. So it performs. Uh, but the problem is with Intel, they don't have the GPU power on its own like how an Nvidia company does. So that they're trying their best. So I would feel if you are into generative AI, you are into AI related tasks which uses this NPUs, neural processing unit. It is always better to go with a dedicated GPU. Obviously, the performance will be very better. Obviously, it will be very better to train and test the models. That is what I'm telling you. You are onto generative AI, then you can go with a dedicated GPU because training and testing the models is very much faster and very much you will see if you are you will just see the difference if you are using deep learning only. You will see the difference. Trust me. Probably you have not you have used. That's why you're not knowing that much because trust me, I'm using deep learning for the past 7-8 years. I remember, I can see the difference in the way they use the GPUs and how the GPU actually uses that course to perform that without a proper dedicated GPU. I cannot even, imagine performing a deep learning training and testing task. Okay, so so you're asking about generative AI, and this generative AI is like one step more than what we do in normal deep learning. So laptop will literally die without a GPU. Literally it will die, it will cry, it all will happen. Okay. Okay, fine. So any other questions, you can just post it in the chat. I'll just continue with this. So next is, let me finish this accelerated computing. Okay, so this is very important because I just wanted to cover this also, especially. Okay, so talking about the accelerated computing, it's a very it's a very important technology which actually gives that acceleration or the boost. Okay, for the GPUs compared to the traditional CPUs. Here I've mentioned here, see, traditional CPUs, because for advanced deep learning and generative and AI related tasks, normal CPUs are not that faster. So you can see the difference by using a normal CPU with without just the internal graphics, and you can use a same CPU but with a dedicated graphic card which is having this ray tracing and CUDA cores. You can see the difference, the training, the testing, the performance in building a model, the way it can run, everything will be different. You can just you can see the difference with your own eyes. Okay, so for example, to build to do something which if the dedicated GPU, if it takes 10 minutes, it will take around 25 minutes to half an hour when it comes to a normal laptop, and without a dedicated GPU, and it will struggle. Normal or a traditional CPU will struggle to perform the task as well. So it's not just about time, it's also about the struggle it will face. So next thing is the core components, which are very important, particularly when you're talking about 5 important components. One is GPU graphic processing unit, right? So it has the tensor matrix, cores which are used. So the next thing is the DPU, which is data processing unit. So this process the storage part, this process the network, it processes the data movement, everything inside the GPU. Then there is called as TPU, which is tensor processing unit. Okay, so this is basically provided or optimized by Google, because this tensors is basically technology of Google. Okay, so next thing is Nvidia's CUDA, which is basically a platform which is used for AI and ML tasks. Just now one person was asking. The software platform enabling GPU programming for AI and ML workloads. You need a dedicated GPU which can have this ray tracing cores and which have this CUDA cores and this tensor cores as well as a dedicated GPU. So Nvidia, Grace Hopper. Next thing is actually Grace Hopper is one more before Hopper actually. Hopper technology, I think. No, after Hopper, yeah. Because before Blackwell, there is Ada Lovelace. That is the architecture before Blackwell. I think the Hopper is before that, or maybe Grace Hopper after that. Before that, Hopper, I guess. Yeah, but exactly remembering, there are some. I think this is 8th or 9th architecture what Nvidia is in. Not, I don't remember correctly, but I think 8th or 9th architecture. Blackwell is some 8th or 9th. Probably you can just Google it. You will be getting. You can just Google that the architectures of Nvidia GPUs. You will get it. Okay. So next thing is how accelerated computing actually works. So this is what actually does. Why I told that what will happen. What will happen if you use these dedicated GPUs? This is what happens in one table I've mentioned. So GPUs can perform billions of matrix multiplications needed to train the LLMs and the diffusion models. So to do this, you need GPUs. One word. Next thing is real-time response generation with models like ChatGPT relies on GPU clusters. Second point. Next thing is GPU enable training across massive data sets with a tensor parallelism and pipeline parallelism. This is what the third point is. Accelerator reduces latency and energy costs when running Gen AI services, which is fourth point. Next thing is GPUs support running image, text, video, and speech models simultaneously. This is the fifth point. So I think I will stop here. I'll just tell this and stop. Okay. Future trends and all, I'll just share the PPT. You can just go through later. So the role of Nvidia inside the accelerated Gen AI or accelerated computing is basically using this Nvidia's DGX, which is for AI trainings. Then they are using this Blackwell and Hopper architectures for trillion parameters LLMs, which is large language models. Then they use the CUDA and CUDNN libraries for deep learning operations. Then we have already talked about NEMO and NEMO frameworks for building domain-specific Gen AI, and they use the tensor ray tracing cores for LLM models for optimizing inference speed. So this is what is, in short, I would say, because 1 hour is not sufficient to talk about Nvidia and its contributions to Gen AI and how Gen AI is actually powered by Nvidia. So I just I've kept only a few things, I would say. Okay. So I don't know how much of justification I have done on this, making you to understand that how Nvidia is basically is used particularly for for these generative AI tasks. Okay, so that is what it is. Any questions if you have, you can just ask me. Before we stop, you'll be having an MCQ test, I guess. Ma'am, you can take over if. What happened? She's not there. Mm. Okay. Chats are disabled. Okay. Hmm. Okay, Ashita, no problem. I'm just waiting for ma'am. She told me to stop by. Okay, so just be online. Uh,
Yeah, I'm sorry, sir. I had some network issue.
Fine, fine.
Yeah, I'll be sharing them as assessment link right now. Yeah, students. So I'll be sharing the assessment link on the chat. Please be waited. As the assessment link will be active till 8:45. You can take till that. I'll be sharing in sometimes. Kindly wait for 5 minutes. Till that, if you have any questions related to subject, please ask to the sir. He will answer for it.
Yeah, so till ma'am shares, you can just ask me if you have any questions.
Yes, students, I have shared the assessment link on the chat. Please start taking the assessment. Read out the questions carefully and understand the question and answer it. It is for 50 marks, 50 questions. So I'll be giving the time till 8:50. Okay, so please read out the questions carefully and start taking it. The link which I have shared it on a same chat. I have shared it in a both YouTube and Zoom. Both I have shared. I hope you all taking assessment. If you have done with the assessment, please don't drop the session. There are the important updates has to tell, and also you have to mark your attendance. So please don't drop the session. If you are done with the assessment, stay online. I hope you all completed the assessment. Please post in the chat if you have done the assessment. Just message me as a done so that I can go for the next step. Please send me done in a chat.
Yes, guys, we're so sorry. Actually, Suchmita ma'am facing some network issue. So I'm here. Uh, how to say I'm here? So Amar is here from XLRT. Okay. So I hope everybody submitted their test, and I know why you're raising the hand. Definitely for the attendance. Yes or no? I will take 10 minutes of your time. Acha, it's already 8:56. Done. Submitted the test. Super. Okay, so for what you are raising the hands? I know everybody submitted the test. Then why you are raising the hand? I am able to see chats are not disabled. You can chat with me. No, sir. 5 minutes. Okay, super. So we are just pending with the two tasks. So how was the test? Is complicated, medium, or easy? How it is? So easy, sir. We learn all these things into the last 15 days now. So that's why. Okay, super. Okay, who is waiting for attendance? Sir, this is not question. Everybody is waiting for attendance itself, right? Exactly, Ashwita. Thank you. Got 49 out of 50. Super. Proud on you guys. I know that everybody got good marks. Haha, yes. I will I will inform each and everything. So see, I said 10 minutes now. I will just take 10 minutes only. In that, I will give you the idea on the certificate. Okay. After that, I will share the attendance link, and I will share some information about the upcoming program as well. Okay, so before starting a talk, I want to assign one task for you guys. Are you excited to do the task? Yeah. See, so guys, sir, but it's shown link is from 8 to 8:30, but submitted 8:50 then. Which link, Akanksha? Okay, okay, guys. Whatever you are doing, that's fine. But let's focus for next 5-10 minutes. I want to give some important information for you. And in addition to that, I want some help from your side. Not help, but it's your responsibility to do that, right? Yeah, exactly. So, dear students, as I believe that you're enjoying the sessions from last 15 days, and we are successfully completed this program. And today is the day 15, right? So, I'm requesting everybody to give the review to us on the program which you enjoy from last 15 days, right? And I'm expecting each and everyone to submit their review. Yes, I'm not expecting, but exactly. Prem, don't worry. I will take your question. Relax. Okay, let me finish. So I'm not expecting, but it's your responsibility to submit feedback and give the review for us, right? So I shared the GMB review link in the Zoom, and I'm sharing over the YouTube as well. So, dear student, just a humble request. I'm giving you the 2 minutes of time to submit the review about the program and help support what you receive from the team of XLR. Okay. Okay. That's fine, guys. If you're not able to submit your test because of some network issue or anything is happening at your end, not any problem. We are just testing your knowledge, what you learned in the last 15 days. There is no any hard and fast rule to certificate you need to have or you need to submit the assessment only. Clear? Okay. So now I am expecting within 2 minutes of time within 2 minutes of time, you guys need to be submit the feedback and review. I'm going to check that personally. So I'm expecting some good responses from you. Once you're going to submit your feedback and review, just reply back into the chat box. That's done. Sir, I have just completed. I have submitted. It is okay, sir. Ha, Prem, it's okay. No issue. Sir, what about those 2 days attendance when classes were not happened on YouTube? Because that 2 days are cancelled, na? So don't you worry on that. Relax. Please replay. Yes. What is your question? I'm just due to low. I said that. Now that's fine. If you're not able to submit, it's okay. That's fine, guys. Review done. Superb. Thank you so much. Others, I'm waiting for your response. Thank you so much, Prashant sir, for giving the review. Thank you, Mohan sir. Thank you so much, all of you. I am requesting everybody to submit review and then we'll move forward with the attendance part. Okay, so I trust on all of you. I believe that you will be submitting the review, but I know that you are waiting for the attendance and feedback as well, as 60% attendance is mandatory to get the certificate. So I'm sharing the attendance and feedback link into the chat box, requesting the students and faculty members to submit the attendance form and feedback form as well. Okay, so as today makes your last day for this program. Yes, Isha, I will be explaining about the certificate. I shared the attendance link over the YouTube. I am sharing the attendance link over the chat box as well. Thank you. Thank you so much. Thank you, Prem. Thank you, Abhijit. Excellent course. Thank you, Pankaj, for your comment. I shared the attendance and feedback link, so please mark the attendance for the day. Prem, yes, I just said that I will explain about the certificate and our upcoming program as well. So, dear participant, those who mark their attendance for at least 60% or more than 60%, then you will be getting your certificate within 10 working days via your registered mail ID. Clear? I am repeating one more time. Those who have marked their attendance 60 and more than 60%, they will be getting their certificate via registered mail ID or attended mail ID within 10 working days. I hope it's clear like crystal, right? Now, next announcement. What next? So see, you will say that, sir, from tomorrow onwards, we are going to miss your classes, sir. We want more information from your side. What next? Hey, no need to worry. If XLR is there, no need to fear. We are coming with the one more program. Okay, we are starting one more program, and that will be starting from tomorrow itself. Tomorrow, yes, exactly. And that program is going to start on DevOps, fundamental of DevOps for 30 hours. Right? So, dear faculty members and dear students, please spread this news across your connections. You can share in your college with the friends and you can attend that program. In that same scenario, it will be happening for next 30 hours from tomorrow onwards, and you will be getting the certificate as well. And please, Muskan, I said that if you're not able to submit, that's fine. We can't increase that time. If see, if you face the network issue, we can't do anything. And that is no any fair on keeping the time and increasing the time. Exactly. I hope you're trying to understand. So no need to worry. I'm saying that now, no need to worry. I'm able to see whatever you are done to submit the test. If network issue, relax. Okay. Now I'm sharing the registration link for the upcoming program. So please mark your registration and you will be getting all the information by tomorrow. You can share the link with your friends, your fellow mates, with your college, and we are coming with the more enthusiasm tomorrow again on a day one. I submitted the review. Super. Thank you. Exactly, Ashmita. I hope you already registered then, as you know the complete program name as well. Super. So now registration link I shared, attendance link I shared the GMB review link as well. I think I'm done from my side. So now those who have some queries or question, anything, whatever you want, you can ask. Thank you, Prem, for submitting your. Definitely, I'm seeing your chat from last 5 minutes. Prem Kumar, I will review your review. This is 30 hours program too. Yes, Pankaj. This will be also a 30 hours training program. Okay, any comments? Anything to ask? Any question? You can definitely ask anything. Parthiv, who will be teaching it? May I know the reason about? Sir, since June 9th, my chat were disabled. No, it is enabled for all. So see, now, however, you are able to chat with me similarly. You can chat with the host and co-host. That you will get to know tomorrow, but definitely I'm giving you the promise on that. You will get more than expected from our side. Okay? We are always here with the industry experts. No, sir. Okay, no issue. I will check with the team. Those who raise the hand, I'm so sorry I'm not able to give the access to unmute yourself. So please post your question into the chat box, any comment, any feedback, any suggestion. We are open for all these things. Quick, guys, last 2 minutes. Sarthak, I said it 2 times. So within 10 working days, you will get your certificate if your attendance is more than 60%. Mohan Vignesh, I'm so sorry, but I can't do anything in that. Yes, definitely. For next program, again, you need to register. See, it will take 30 seconds hardly, right? They completed their test. That's why they raised their hands. Oh, okay. Thank you. Thanks for help. No any comment, no any feedback. I'm just surprised. Why? Maybe it's dinner time, so everybody wants to go. Sincere appreciation to the XLR team for organizing such as a useful 30-hour session and special. Thank you so much for your comment. Thanks to Shashank sir. Yeah, definitely. Thank you so much from my end as well to Shashank sir for delivering 30 hours of training program. Thank you, Ashwita, to me as well. Thank you to Dushmita Mama as well for being with you for last few days and helping you with the attendance and your queries and questions. Thanks to entire XLR team. Thank you so much, Pankaj sir. Thank you for teaching us. Thank you, Prem Kumar. Yeah, thank you so much, Ashwita. Okay, so thank you so much, guys, once again for making this program successful. And I'm definitely going to see you tomorrow with the new energy, with the new expectation, with the new agenda on day off. So let's crack it together. And we'll see you tomorrow sharp at 7 o'clock. So let's meet again. So till the time, take care of yourself, take care of your family, and bye-bye. Have a nice time ahead. and have your dinner and take care. Bye bye. Happy learning with Excel. Okay, so I'm sharing the 1 second attendance link and then we'll close for the day. Thank you so much, guys, and see you tomorrow. Bye bye. Okay. DevOps links. Okay, no worries. I will share that again. Registration link. I will be more than happy to see all you guys there again in the new program which we are going to start from tomorrow. On this note, bye bye and thank you.